Good evening. We are talking about a chapter in grade 6 and the chapter is called as Understanding Elementary Shapes. The line segment is very easy to understand, but the important point of this chapter start when we start measuring the angles. So I made a presentation on that and let's just see. Let's use this for the sake of revision of this chapter. Now how can we measure these angles? The angles are measured by using the protractors. So this is a protractor, I kept the protractor here. It has to be mounted where this line of the protractor and this line of 90 degrees here, when they coincide exactly at that point, where the two lines coincide, exactly at that point, the vertex of our angle must be. So the vertex must be here, absolutely matching with these two lines. That is the first requirement. The second important requirement, which we should not miss at all, is this line is our zero reference line. One of the two arms of the angle, one of the two arms, any one arm, must perfectly coincide with this zero line, this reference line. Once that happens, the two requirements are satisfied. The vertex matching with this vertex, the point, and the line or the one arm of the angle perfectly coinciding with this reference line. If both the conditions are satisfied, we are perfectly good to go with our reading. Now see how we take our reading. Measurement should start from that side where 0 is on the reference line. If on the reference line the 0 stands here, so we'll take 0, 10, 20, 30, 40, 50 and 55. So this angle is 55. So this angle here is 55 degrees. Somebody might calculate or might think a measurement of this angle to be in the opposite way. We start 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120 and 125. Now somebody will say, sir, the answer is 125 and somebody will say the answer is 55. Which of them is right? The important point is you must measure the angle starting from the reference side, starting from that arm of the angle which is actually coinciding with the zero value. That is where your measurement should start, and that is coinciding here. So the measurement should start from here. So 0, 10, 20 is the right measurement. 180, 170 we should not indulge in that. The measurement cannot start here because the reference line is on this side, because the arm of the angle is on this side. So this is 55 degrees is right, 125 degrees wrong. In this case again, although one would think that starting with 0, 10, 20, 30, 40, 50, 60, 65, that's not right, because our angle's reference line is starting here. The two arms which make the angle, one arm is this and the other arm is this. And what we want is the arm which is coinciding with 0. From that angle, from that arm, the measurement of the angle should start. So we'll take 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 115. 115 degree is the measurement here. So this is how we can measure the angle. The measurement of the angle will continue. We'll do it with the next slide as well. Let's move on to the next slide. This is a problem from the textbook. I only taken the photo screenshot of that and we'll try to measure these angles now. Let's see. Yes. Now we have the protractors coming here. Again, if you see, closely if you see, there is a mistake here. The line was here and I'll draw it. Let's see if we can get it accurately. The arm of the angle is here and my 0 is here. There is a little bit of gap there. Although the gap is not as bad, as large as I have made it look like, it is an exaggerated version. It's not like that. But if you carefully see, there is still some deviation. Ideally, your 0 on the protractor should match with the center of the line. this line center should perfectly coincide with the 0. So I not placed it properly, I am telling you that. What will be the result of this? I think we'll introduce a half a degree of error will come in the picture, I think, or maybe slightly less than that. Let's see. But the angle would be measured from here up to this line. So 10, 20, 30, 40, 41 degree. So this is coming out to be 41 degree. I might be tempted to think that this would have been 40 degree if I had placed it right. But maybe not, maybe it was 41 degree or maybe slightly on the other side as well. 41 degree is the reading that we are getting. As far as this angle is concerned, both the arms, this arm and this arm, are none of them are horizontal, they are all tilted. It is okay, we don't mind that. Our cross lines must match with the vertex, they are matching. One line must perfectly match with the 0. Now the 0 is coming between 0 degree and 1 degree. In between that, again there is an error on my part, a little bit. I am showing you the errors that we can encounter. So this is 10 degree, 20, 30, 40, 44 degree. So our reading will be 44 degree here. Again, if this error was not encountered, maybe this reading may have come 45 degree. So again, we have to be very cautious when we are measuring the angles. Let's see the next ones. Come on. Yeah. We'll measure these angles. It's very simple now. 0 degree, 10, 20, 30, 40, 50, 60, 67 degree. So this comes out to be 67 degree. There is no measurement and there is no angle error here. The line is perfectly matching the arm of the angle, and this line, reference line, is perfectly matching. So there is no error here. It's coming exactly 67 degree. In this case as well, the angle is almost zero, no error here. So this is 10 degree, 20, 30, 40, 50, 57 degree here. 57 degree, 67 degree are the two angles here. Let's see the next one. If we have a clock and the clock is showing 9 o'clock, where the hour hand is pointing at 9 and the minute hand is pointing at 12, then what will be the angle between the hour hand and minute hand? For one, the calculation should be done without measurement as well. It should be very easy. So how is that done? Let's see that quickly. When there are 12 hours, it is complete one rotation. So 12 ka deviation of 12 is like 360 degree. So if this minute hand moves from 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 9, 10, 11, 12, it comes back here. So there is 360 degree of rotation. If the hour hand goes through 12 hours, it will come back and it will be pointing at 360 degrees of rotation. But in this case, now the hour hand is at 9. For the hour hand to perfectly match with the minute hand, this should go from 9 to 12. So we are talking about a time gap of 3 hours. 9 to 10 is 1 hour, 10 to 11 is 1 hour, and 11 to 12 is 1 hour. 1 hour, 12 hours is 360 degree. 1 hour, we are dividing by 2, we are dividing by 12, we will divide by 12 here, it is 30 degree. 1 hour is 30 degree. Here we are talking about 3 hours. So 3 hours will be 30 into 3, 90 degree. So this measurement should be 90 degree. This should be 30 degree because it is only 1 hour. But this is theory. What we are talking about is calculation by theoretical logic. What will happen if we keep the protractor in place and what will be the angle? Let's find it. So we got the protractor here. Our measurement will start from this 0 here. 0, 10, 20, 30, 40, 50, 60, 70, 80 and perfectly coinciding with 90. So this angle is 90 degree. Here it is perfectly coinciding with 0. Your measurement is starting here. The 0 upper, lower 0 is taken 0, 10, 20 and 30. It is perfectly coinciding with 30 degree. As it was expected, we were expecting that this angle will be 90 degree, this angle will be 30 degree, and it has come to be like that. The next one, all these angles, this is 40 degree, this 0 is not matching, it's a part of my part. This 0 is perfectly matching from 0 up to this one 31 degree. This is, if you take this angle, it will be 0, 10, 20. If you take from 0 here, 10, 20, 30, 40, 45 degree, if you take it this angle. But if you take this angle, it will be 130, 135 degree, which is fine. This is 45 degree, this will be 135 degree. But if you remove the protractors, you will see that this angle was asked to be measured. So this is 135 degree. And we are asked about this angle. 0, 10, 20, 30, 40, 60, 65 degree, almost 65 degree. So that is how we can measure these angles. The exercise 5.5 is just about the line segment and the angle between the two lines. Let's see that. It's very easy to, it's difficult to talk about it, but it's very easy to solve this. So let's just quickly solve this. Which of the following models are perpendicular lines? The adjacent edges of a tabletop. The tabletop will also have the same kind of edge, slightly curved on the other side, on the periphery, but despite being curved on the edge, the angle between the two lines will be 90 degree. So this will be a 90 degree. It is right. Or we can say yes. The second lines of the railway track are parallel lines. They are not perpendicular lines. These two are parallel lines, railway track. They are not perpendicular. The line segment forming the letter L, surely they are perpendicular lines. Although we sometimes draw it like this, but the fact is we always know that L is actually perpendicular lines. Letter V is not. We never draw V like this. Or even this is not perpendicular. Perpendicular lines would be like this. We never draw V like this. We draw V like this. The angle is an acute angle, not perpendicular. Not 90 degree. This is not a right angle. Let PQ be the perpendicular to the line segment XY. PQ, this is P, this is Q, and they are perpendicular. Line segment XY. X, Y, perpendicular. How do I know the diagram is like this? I don't know. I just know that PQ line segment is drawn. I have drawn the line segment. XY is one more line segment, but it is perpendicular. So I draw a perpendicular line segment. That's it. So this is perpendicular. They intersect at point A. So the intersecting point is A. What is the measure of angle PAY? PAY. Come on, this is right angle, 90 degree. These two lines are perpendicular to each other, so the measure will be 90 degree. So the answer of this question number 2 is 90 degree. Question number 3, there are two set squares in your box. What are the measures of the angles formed at their corners? You can check the set square. We have discussed this in the class. One set square has angle 30, 60, 90. And the second set square has 45 degree, 45 degree, 90 degree. So the angles of the set squares are always like this. There are two set squares and they always have this angle. The one set square will have 30 degree, 60 degree, 90 degree, and the second will have 45 degree, 45 degree, and 90 degree. This is because there are two very special triangles that are formed. One is 30, 60, 90 triangle. This is 30, 60. This is 30 degree, 60 degree, 90 degree triangle. This is a very special triangle in geometry. You will understand the value of this once you learn trigonometry. 30 degree, 60 degree, and then 45 degree are very special angles. 45, 45, this is 45, 45, 90 degree. So one set square is like this set square is like this in shape. The angles are 30 60 90 and 45 45 90. Study the given diagram. The line L is perpendicular to line M. Is CE equal to EG? CE and EG, yeah, they are equal. 3 to 5, 2 ka distance. 5 to 7, distance is 2. So they are equal. Yes. Does PE bisect CG? Where is PE? PE. Is this line bisecting CG? C to G. Yeah. C to G has been bisected. Bisected, the meaning of the word bisect is divided into equal parts. So this is one part, this is second part, two equal parts. Bisect. Yeah. Yes. Identify any two line segments for which PE is a perpendicular bisector. Perpendicular bisector is that bisector. Bisector will bisect into two equal parts. Perpendicular, it has to be perpendicular. So that is perpendicular bisector. Bisector as well as perpendicular. So this from PE must be a perpendicular bisector. It is DF, CG and BH. I am writing the answer. DF, CG and BH. One on this side, one on this side. It's DF. Two on this side, two on this side. CG. Three on this side, three on this side. BH. So these are the three lines which are being perpendicularly bisected by PE. Are these true? AC is greater than FG. AC is greater than FG. Yet this is 2, this is 1. Yes, it is true. CD is equal to GH. CD is equal to GH. Where is CD? CD is here. And where is GH? GH is here. Don't worry about this. This is not an origin. We are not measuring distance from here. We are measuring distance between them. 1, 1. They are equal. And BC is less than EH. Where is BC? BC is here. EH is 3 and BC is 1. Yeah, it is less. Yes, it is less. Exercise 5.5 khatam. We'll start with the next exercise 5.6. This is even simpler. Name the type of the triangle 7 centimeter, 8 centimeter, 9 centimeter. So the type of the triangle here is, name the type of the triangle 7, 8, 9. A triangle in which no sides are equal are called as scalene triangle. SCALENE. Scalene triangle. So this is the answer for question number 1. ABC 8.7 is AB, AC 7 and BC 6. ABC 8.7, AC 7 and BC 6. It is scalene triangle as well. None of the sides are equal, so it is a scalene triangle. PQ is equal to QR is equal to PR. PQR. Please bear with my drawing. PQ is equal to PR is equal to QR. All three sides are equal. If all three sides are equal, it is called as equilateral triangle. Equilateral triangle is this. Question number 4. DEF with angle D equal to 90 degree. If one angle is 90 degree, all angles are absolutely not going to be 90 degree. If one angle is 90, then that triangle is called as a right angle triangle. So this is a right angled triangle. In XYZ triangle, angle Y is 90 degree. Measure of angle Y is 90 degree. And XY is equal to YZ. Okay, so we'll draw this triangle now. This is the triangle. Angle Y is 90 degree and XY is equal to YZ. These two sides are equal. If the two sides are equal, it is isosceles. And if it is a right angle, it is a right angle. So it is an isosceles. ISOSCELES. Isosceles right angled triangle. Sometimes in short people call it isosceles right triangle. Angle LMN, triangle LMN with angle L 30 degree, measure of angle M 70 degree, measure of angle M 80 degree. All three angles are less than 90 degree. So they are all acute angles. So it is called an acute angle triangle. That is the answer for question number F. Now we will solve question number 2 here. What is question number 2 saying? Let's see that. I'll just enlarge this slightly. That's the best we can get, I think. Three sides of equal length. If there are three sides of equal length, they are called as equilateral. Ka equilateral? Three sides of equal length. Equilateral. E. So first answer is E. Second, two sides of equal isosceles. Isosceles is here. There is isosceles, but it is right triangle. It is not given to be right angle. So it is isosceles. G. Second answer is G. Third, all sides of different length. Scalene triangle. A. Three acute angle triangle F. One right angle triangle D. One obtuse angle triangle C. One right angle with two equal lengths, isosceles right angle B. And we are done. Matching the pair is finished. Now, so question number 3. Name each of the following triangles in different ways, two different ways. You may judge the nature of the angles by observation. This is 5, 5, 8. It is, if the two sides are equal, this side and this side is equal. So they are isosceles for sure. This angle is an isosceles triangle for sure. But all angles are acute. All angles are less than 90. So it is isosceles acute angle or isosceles triangle, or we can say acute angle triangle. So there are two names, two different ways naming isosceles triangle or acute angle triangle. This is 8, 15 and 17. How do we see this? This is a scalene triangle and it is a right angle triangle. The angle is right angle, but the sides are not equal. So it is scalene because none of the sides are equal. Right angle because one angle is 90 degree. 7 and 7. So if two lines are equal, it is an isosceles triangle. And the second naming will be, because one angle is obtuse, it is an obtuse angle triangle. Obtuse angle. Here it is 10 centimeter and 10, I think it is 10 as well. Let's see this. Yeah. This is 10 centimeter, this is 10 centimeter. So, first name of this will be, this is an isosceles triangle, but it is also a right angle. So, the second name will be right angle triangle. 5.2, 5.2, 5.2. Equilateral triangle, but all angles are less than 90 degrees. So, it can also be called as acute angle triangle. Equilateral or acute angle. 9, 10 and 15. None of the sides are equal. So, scalene triangle and one angle is the greater than 90 degree, obtuse angle triangle. So, these are the two names for this. Alright, we are done with 5.6. It's a very simple exercise actually. No, one more. Try to construct triangles using matchsticks. Here are some shown below. Can you make a triangle with 3 matchsticks? Oh yes, we can make a triangle with 3 matchsticks. Hello? One matchstick, second matchstick, third matchstick. We can make a triangle like that. So 3 matchsticks, yes. 4 matchsticks, no. I had tried that. If in one class I remember I had solved this. There are 2 matchsticks here, and I thought ki one matchstick here and one matchstick here, 4. But the problem is with 2, if this is the size of the matchstick, I cannot have this line so large. All the matchsticks must be of the same size, and then it is not possible. If you draw 2 matchsticks here like this, one matchstick, second matchsticks here, then there will be no other point where one and one matchstick will match. So you cannot construct this kind of triangle, because this side and this side, addition of the 2 sides must be greater than this, the third one, and they are coming equal. You will not get a right angle. You will not get a triangle in this case, because it is impossible to draw this. You can have this. The second, there is no other point which is at distance 1. It is impossible to draw a triangle with 4 matchsticks of equal length. So it is no. 5 matchsticks, well, we can see this. 5 matchsticks is like you have 1 and 2 and 3 and 4 and this is 5. It is perfectly fine. This is possible. So 5 is possible, yes. 6 matchsticks, of course, possible. Six matchsticks together can form the triangle, yes. Only 4 matchsticks is not possible. Why is it not possible? Why can we not have this? This is 1 and 2, and there can be third point where we have this or this. It is not possible. It does not work like that. Why? Because there is a theorem in grade 7 that you will study next year, and that will explain this. I will encourage you to think about this. If you can get the answer, please come and tell me. I think we solved this. We'll now start with the last 2 exercises. These are very simple ones. We'll just quickly get rid of this. Answer in true or false. Sometimes, I don't know why, but some of our textbooks exhibit a beautiful example of bad English. This is one of the examples. Say true or false is a very bad way of writing. State whether the statement is true or false is how it should be written. But anyway, each angle of a rectangle is a right angle. It is true. In a rectangle, all 4 angles are equal and they are 90 degrees. A rectangle is a special case of a parallelogram. The only thing that is special is these angles are 90 degrees. Because in a parallelogram the opposite sides are equal, in the rectangle opposite sides are equal. In a parallelogram the diagonals are bisectors of each other. In a rectangle the diagonals bisect each other. In a parallelogram, this angle is not 90 degree, and in a rectangle, this angle is 90 degree. And because of the 90 degree, the shape that you get makes the diagonals equal as well, which was not there in parallelogram. So, but basically, a rectangle is a special kind of parallelogram, and the speciality being about the angle. All the angles are 90 degree. The opposite sides of a rectangle are equal in length. Yes. Opposite sides are equal in length, they are parallel as well, equal as well. Diagonals of a square are perpendicular to one another. Yes, that is right. Square will have diagonals perpendicular to each other. If I draw the perfect square, this will come at perfectly 90 degrees. All sides of rhombus are of equal length. Yes. Rhombus have all sides equal. Rhombus is a special kind of parallelogram where the speciality is in a parallelogram the opposite sides are parallel and equal. Parallel and equal. In a rhombus, all sides are equal in there. So even adjacent sides are equal. Every side is equal. All the sides of a parallelogram are of equal length. No, false. Yeah, yes, like true. I think you understand this. This is true, and true. This is false. The opposite sides of a trapezium are parallel. Now this is a very tricky question. It should not be like this. The opposite sides of a trapezium are parallel. Trapezium is this. This is one side, this is the second side parallel to each other. But these two sides are not parallel. Which are the opposite sides now? If we call these two as opposite, they are not parallel. If we call these two as opposites, they are parallel. Now our answer is based on an assumption. I assume that the question is about these two sides. And if the question is about these two sides, then they are parallel. Then the opposite sides of trapezium are parallel, that's true. But if the question is about these two sides, they are not parallel. If the question is intending to ask about generally about all the sides, ye opposite side, this opposite side, then even in general this is false. Only in this case of only these two lines, that the lines are parallel. Give reasons for the following. A square can be thought of to be a special rectangle. Yes, I have ample reason for this. A rectangle is like this, where all angles are 90 degrees. A square has all angles 90 degrees. In a rectangle, opposite sides are equal and parallel. In a square, opposite sides are equal and parallel. In a rectangle, the diagonals are bisectors of each other. In a square, the diagonals also bisect each other. But the square is also having some specific and special properties. The diagonals will not only bisect each other, they will be perpendicular as well. This is one property. Second property, the square has not only the opposite sides equal, the adjacent sides are equal as well. And this makes the square special. So the square can be thought of as a special rectangle. A square is a rectangle, but it's a special kind of rectangle. A rectangle can be thought of as a special parallelogram. I encourage you to solve this problem. We have discussed this in the class. A parallelogram has opposite sides equal and parallel. A rectangle also has opposite sides equal and parallel. A rectangle, only one thing that the rectangle does not have is all angles 90 degree. The parallelogram does not have all angles 90 degree, but the rectangle has. A square can be thought of to be special rhombus. Yes. This is rhombus. This side equal, opposite side, all sides are equal, opposite sides are parallel as well. Here as well, all sides are equal and opposite sides are parallel as well. Only speciality be all angles are 90 degree. So yeah, we can say this is right. The square is a special case of rhombus. Squares, rectangles, parallelograms are all quadrilaterals. Of course, a quadrilateral is something that is a geometrical figure formed by 4 different points, joined by 4 different sides and making 4 angles. All is true with this. So all are special quadrilaterals. A square is also a parallelogram. Yes, because square is a rectangle, rectangle is also a parallelogram. Square is also a parallelogram. Like question number 3, a figure is said to be a regular if its sides are equal in length and angles are equal in measure. Regular तब होगा जब if all the lines are equal in length and if all the angles are equal in measure. Can you identify the regular quadrilateral? Quadrilateral whose all lines are equal. It could have been this. All lines are equal, but the angles are not equal. See, these angles are not equal. So rhombus cannot be that. Has to be square. All lines equal, all angles 90. Has to be square. Alright, so we're done with 5.7 as well. We just left with only one, 5.8. Examine whether the following are polygons. This is not a polygon. Polygon has to be a closed figure. It is an open figure. ये तो भूल भुलैया है. It's not a polygon. So this is a polygon. This is not a polygon because the curves are not there, only straight lines. The curves are not there, only straight line. Only one is polygon B. Name each polygon. 1, 2, 3, 4. 4 sides. This is a quadrilateral. This is a triangle. 1, 2, 3, 4, 5. Pentagon. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Octagon. If there are 6 sides, it would have been hexagon. If it would have been 7 sides, septagon. And so on. Question number 3. Draw a rough sketch of a regular hexagon. Okay, regular hexagon, rough sketch. Connecting any 3 of its vertices. Draw a triangle. Any 3 vertices. This and this. Draw a triangle. Identify the type of triangle if you have drawn. This triangle is, what do you say? One angle is greater than 90 degree. It is an obtuse angle triangle. Or this can be an isosceles triangle as well. See that this side and this side will be equal. Regular hexagon, in a regular hexagon, all these sides are equal in length. So this side and this side will surely be equal. So it will be a isosceles obtuse angle triangle. Any triangle that you draw, this and this, let's say, is an isosceles obtuse angle triangle. Obtuse angle, isosceles because two sides are equal. Question number 4. Draw a rough sketch of a regular octagon. Okay, this is regular octagon. Why draw a rough sketch? It is there. It is not regular, slightly odd angle here, but let's consider this. Draw a rectangle by joining exactly 4 vertices of the octagon. This is a very good question. I draw a rectangle like this. You see a rectangle here? There is one more rectangle I can draw. So this question is sorted. There are 2 rectangles that we can draw. And you know, if I draw both the rectangles here, then I will also get a square in the center. This is square. Next, a diagonal is a line segment that joins the 2 vertices. A diagonal is a line segment that joins any 2 vertices of the polygon and is not a side of the polygon. Draw a rough sketch of the pentagon and draw its diagonals. Okay, I'll draw the rough sketch and then I'll explain that to you. From this, join any point, but it should not be making a side of the. So you don't count the adjacent points, the points which are immediately next to it, and take the other 2 points here. There are 2 points available. This is the diagonal, or this is the second diagonal. So in a pentagon, starting from any point, you can draw 2 diagonals. In a quadrilateral, starting from any point, you can draw only 1 diagonal because this is side, everything is side. ये side है, ये side है. यहाँ से सिर्फ only 1 diagonal is possible. So this is what we have done. We have drawn the diagonal. Are we left with anything else? No, we have reached the end of the document. Yeah. So that covers the entire chapter. I hope you understood this. Study well. All the best.